Welcome to a deep dive into React hooks. In this video, we're going to explore what React hooks are, how to use them, and some advanced patterns to help you build better React applications. This is your guide to mastering React hooks. So, what exactly are React hooks? Hooks are, in essence, functions that allow you to tap into React features from functional components. Before hooks, these features were primarily available in class components. Hooks enable state and lifecycle management, among other things, without the need to write class components. Let's look at a basic example. Here's a simple counter component using the useState hook. We import useState from React. Inside our counter function, we declare a state variable count and a function setCount to update it, initialized to 0. The button, when clicked, uses setCount to increment the counter. No classes, no this keyword, just simple and clean functional code. Before we dive deeper, it's crucial to understand the rules that govern how hooks should be used. There are two primary rules to keep in mind. Firstly, only call hooks at the top level of your functional component. Do not call hooks inside loops, conditions, or nested functions. Secondly, only call hooks from React functions. This means they should be called within a React functional component or a custom hook. Let's illustrate what not to do. Here's an example of incorrect usage. As you can see, the useState hook is placed inside an if condition, and the useEffect hook is inside a loop. This violates the rules of hooks and can lead to unexpected behavior in your React components. Always ensure hooks are called unconditionally at the top level of your component. Let's explore some advanced patterns using the useState hook. First, we have functional updates. Instead of directly passing a new value to the setCount function, you can pass a function that receives the previous state as an argument. This is especially useful when the new state depends on the previous state. For example, to increment the counter, we use setCount, prevCount equals prevCount plus 1. This ensures you're working with the most accurate previous state. Next, we have object state updates. When dealing with state that is an object, make sure to update it correctly by using the spread operator. Instead of mutating the existing object, create a new object with the updated properties. For example, to update the age of a user, we use setUser, previous equals previous, age 26. This creates a new user object with the updated age while preserving the other properties. Finally, lazy initial state. If the initial state is a result of an expensive computation, you can pass a function to useState. This function will only be executed once during the initial render. This can help optimize performance, especially when the initial state doesn't need to be computed on every render. Similarly, you can read a value from local storage as the initial state, ensuring it's only read once. Let's dive into some advanced patterns for the useEffect hook. UseEffect is used to perform side effects in functional components. Side effects could be anything like data fetching, subscriptions, or manually changing the DOM. First, cleanup and dependencies. The useEffect hook can return a cleanup function that is executed when the component unmounts or before the effect is rerun. This is useful for cleaning up resources like timers or subscriptions to prevent memory leaks. For example, if we set up a timer using setInterval, we can return a function that clears the interval using clearInterval. We also include an empty dependency array to ensure this effect runs only once when the component mounts. Next, conditional effects. The useEffect hook allows you to specify dependencies. The effect will only run when these dependencies change. This is useful for optimizing performance and preventing unnecessary re-renders. For instance, you might want to fetch user data only when the user ID changes. This way, the effect is skipped if the user ID hasn't changed, preventing unnecessary API calls. You can also skip effects entirely by providing an empty array as the dependency, ensuring the effect runs only once during the component's lifecycle. One of the most powerful features of React hooks is the ability to create custom hooks. Custom hooks allow you to extract component logic into reusable functions. This promotes code reuse and makes your components more readable. The naming convention for custom hooks is to start with use. Let's create a custom hook called useCounter. This hook encapsulates the logic for a counter, including the state and functions to increment, decrement, and reset the count. We declare a state variable count and functions increment, decrement, and reset to modify it. We then return these functions and the count. Now let's see how to use this custom hook in a component. In our counter component, we use the useCounter hook and destructure the returned values. We can now use the count state and the increment and decrement functions in our component. Custom hooks help keep your components clean and reusable. When dealing with more complex state logic, useReducer can be a better alternative to useState. useReducer is a hook that is used for managing complex state transitions by using a reducer function. A reducer is a pure function that takes the previous state and an action and returns the new state. This pattern is similar to Redux. Let's define a counter reducer function. This reducer handles 3 actions: increment, decrement, and reset. Based on the action type, it returns a new state with the updated count. In our counter component, we use the useReducer hook, passing the reducer function and an initial state. The useReducer hook returns the current state in a dispatch function. We then use the dispatch function to send actions to the reducer, triggering state updates. useReducer is particularly useful when dealing with state that has multiple subvalues, or when the next state depends on the previous one. React provides hooks specifically designed for performance optimization, useMemo and useCallback. Let's explore these. useMemo is used to memoize the result of a computation. It only recomputes the value when one of the dependencies has changed. This can be especially useful for expensive computations that don't need to be rerun on every render. For example, if we have a heavy computation function that takes a long time to run, we can use useMemo to ensure it only runs when the data changes. Similarly, we can use useMemo to filter a list of items based on a search term, only refiltering when the items or the search term changes. useCallback is used to memoize a function. It only returns a new function instance when one of the dependencies has changed. This is useful for preventing unnecessary re-renders of child components that rely on the function. For example, if we have an onItemClick function that is passed as a prop to a child component, we can use useCallback to ensure the child component only re-renders when the function changes. Using useMemo and useCallback can significantly improve the performance of your React applications. Let's discuss useRef and useContext, 2 more essential React hooks. useRef is used to create a mutable reference that persists across renders. One common use case is to access DOM elements directly. For instance, we can create an input ref using useRef, null, then attach it to an input element using the ref prop. This allows us to programmatically focus the input element using inputRef.current.focus. useRef can also be used to store any mutable value that doesn't cause a re-render when changed. Now let's talk about useContext. useContext is used to consume values from a React context. Context provides a way to pass data through the component tree without having to pass props down manually at every level. First, you create a context using createContext. Then you provide a value to the context using themeContext provider. Finally, you can consume the context value in a component using useContext themeContext. This allows you to access the theme value without having to pass it down as a prop. To wrap things up, let's review some best practices when working with React hooks. Keep effects focused and minimal. Ensure that your side effects are concise and perform only necessary tasks. Use dependency arrays correctly. Include all dependencies that your effect relies on to prevent stale closures and unexpected behavior. Optimize with useMemo and useCallback. Memoize expensive computations and functions to prevent unnecessary re-renders. Create custom hooks for reusable logic. Encapsulate complex logic into custom hooks to promote code reuse and readability. Always clean up side effects. Return a cleanup function from your useEffect hook to prevent memory leaks. Hooks enable powerful patterns for state management, side effects, and component optimization in React functional components. By mastering these patterns, you can build performant and maintainable React applications. That concludes our deep dive into React hooks. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.